We'll continue with the same question that we had for the previous problem. Again, 41% of Americans have brown eyes, and we have a random sample of 21 people. And now the question is, what exactly is the probability that exactly 10 of them have brown eyes? So for this, let's enter the data that we have here. We need a sample size, or an N, of 21. We have a probability of success for each person of 41%. And then we need exactly 10 people. So to find the probability of getting exactly 10, for our x, we can use the Binom dist range function. Let's first draw a picture for this. The lowest possible value for x is 0, and the highest is 21. But we want exactly 10. Now, if you're looking for an exact number using binom dist range, we would say equals binom.dist.range. We would first enter the number of trials, or n, the probability of success next, 41%, comma, the exact number we're after, which is 10. Then close the parentheses. Let's enter it now, equals binom.dist.range. We click the 21 because that's our n, comma, the probability, comma, the exact number that we're after, that's 10. Close the parentheses and press enter. And this gives us the probability of having exactly 10 people having brown eyes. Problem D has a slight difference from problem C. It asks the probability that at least 10 have brown eyes. That's a completely different problem, and let's make another drawing to go with it. Once again, the lowest we can go is 0, and the highest we can go is 21. But at least means greater or equal. The words at least will pop up in a lot of problems that you'll see. This means greater or equal, also symbolized by this symbol. A greater than sign over a bar, this means greater or equal. Now, once again, we start with 10, but we're interested in everything that is 10 or higher. Now, if we're going through a range in binom dist range, there's a slight modification to the formula. We'll still use binom.dist.range. We'll still say n for our first entry, probability for our second entry, the low number in the range, then the high number in the range. So we'll make labels for each of these with n, p, low, and high. Our n will be the number of samples, that's 21. The p is 41%. The lowest number in the range is 10, and the highest is 21. So to find the probability that x is greater than or equal to 10, we say equals binom.dist.range. We click the n, comma, click the probability, comma, click the low, comma, click the high, close the parentheses, and when we press enter, we'll have 0.34276. In this problem, we are asked what's the probability that less than 9 of them have brown eyes. So once again, make a drawing, starting from 0 and going to 21, and they want strictly less than 9. Now, when they say less than, we actually don't count the 9. So I'll draw a red X where 9 would be. We'll need to go one lower than that and start with 8. However, we want to go less than 8, not greater than 8, so we'll shade in green the area between 0 and 8. Now the setup is similar to what we've already done. We'll have in, p, low, and high. The in will be 21 still, the probability will still be 41%. The low number is now 0, and the high number is now 8. We'll reuse our binom dist range formula from part D. So the probability that x is less than 9 will be equals binom.dist.range. And once again, we'll say n, comma, p, comma, low, comma, high. Close the parentheses and press enter. This will give us our probability that x is less than 9. Now we are asked, what is the probability that at most 8 of them have brown eyes? First, let's look at the definition of at most. Now, when they use the words at most, they mean less or equal to 8. So we can be at 8, or we can be less, but we can't be more. Once again, let's draw a picture. Once again, we start at 0, end at 21. We'll make a mark for 8, and we want to go strictly less than 8, or including 8. We'll make a mark at 8. 8 will be part of the answer, but we can also go less. So, once again, we'll use the formula for binom.dist.range. First, we place our size of the sample, n, the probability of having brown eyes, our lowest number in our range, and our highest number in our range. We put labels in column A, n, p, low, and high. The size of our sample is 21. The probability is still 41%. Our lowest value is 0, and our highest value is 8. Now, to find the probability of being less than or equal to 8, we say equals binom.dist.range, click the n, comma, p, comma, low, comma, high. And when we press enter, we get 0.48603. Now in part G, we are asked the probability that more than 7 have brown eyes. Now, this doesn't mention being equal. It says strictly more than 7. So more than means don't include 7. When we draw our picture, place a mark at 0 and a mark at 21, and we'll place a red X on 7 to remind ourselves not to include it. Now we want to go more than that, so more than 7, next number up is 8. And we're going to include everything from 28 upward to 21. So once again, we'll use the same formula, binom dist range, with n, p, low, and high. Our n is still 21, and our p is still 41%. Our low value is now 8, and our high value is 21. So we'll say the probability of being x more than 7, use binom.dist.range, click the n, comma, p, comma, low, comma, high. Close the parentheses, and we'll get the probability of being greater than 7 is 0.68453. For part H, let's draw another picture. This asks us the probability of being at least 4 and no more than 8. Now, at least means greater or equal. And no more than means less or equal. Now, we're greater than or equal to 4, but less or equal to 8. So really, this means we are between 4 and 8. If we draw a picture for this, first we place our 0 and our 21, but we want to be between 4 and 8. It says greater or equal to 4, less than or equal to 8, and that means we are going for the region in between. So we'll have our N, P, low, and high. N is still 21, P is still 41%, low is now 4, and high is now 8. So our probability of being between is going to be equals binom.dist.range. We'll click the N, the P, the low, and the high. When we press enter, we'll get 0.47735. The challenge in this problem is being able to sort through the words at least or no more than. We need to know whether we are including the numbers or we are excluding the numbers, as in problem G. So if you ever see more than or less than, that's exclusive. That means we're leaving that number out. That means we're going to put an X on the number. However, if they say at least or at most or no more than, we have a different situation. You may also see no less than. In that case, the number is included. So be on the lookout for these patterns of words when you're dealing with binomial distributions.